Alright guys, let's start solving some quadratics using our quadratic formula, everyone's favorite. So first slide in your notes right here is just telling us what our quadratic formula is. Remember that the important thing for our quadratic formula right here, it has to be set equal to 0 before you can use that quadratic formula. So add, subtract, whatever you have to do to get everything on one side so that's set equal to 0. Then you can use your quadratic formula. Right over here, our solutions are going to be equal to the opposite of b. Opposite because if b was negative, it becomes positive. So opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Okay, that plus or minus is where we get those two solutions. Quadratic formula, opposite of b plus or minus square root of b squared minus 4ac all over 2a. That is something that you have to memorize. Alright, so to solve this one out, again, that first thing we need to do is make sure everything gets over here on the same side as our x squared. So I'm going to subtract 33 from both sides and get x squared minus 8x minus 33 is equal to 0. Now that we have that, we have a is equal to 1, b equals negative 8, and c equals negative 33. So we're going to plug these all into our opposite of b. Opposite of negative 8 is 8, plus or minus the square root of b squared. Negative 8 times negative 8 is 64. b squared minus 4 times a times c all over 2a, 2 times 1. All right, order of operations, remember this square root is a grouping symbol, so everything under there needs to be done first. So I'm going to do 4 times 1 times negative 33, and I get negative 132. So I have 8 plus or minus the square root of 64 minus negative 132 becomes plus 132 all over 2. 64 plus 132 is 196. 8 plus or minus the square root of 196 all over 2. Square root of that answer gives us 14. So I have 8 plus or minus 14 over 2. 8 plus 14, that's 22 over 2. 8 minus 14, so we have 11 and negative 3. And those are our two solutions to this quadratic. Next one, same type of thing. Again, make sure you get everything to this side with the x squared first. It has to be set equal to 0. And now we just plug it all in. Opposite of b plus or minus root b squared minus 4 times a times c all over 2 times 1. 4 times 1 times negative 30 gives me negative 120. 169 minus negative 120 is plus 120. Negative 13 plus or minus all over 2. 169 plus 120. I have negative 13 plus or minus the square root of 289 all over 2. The square root of 289 is 17. Negative 13 plus or minus 17 over 2. Negative 13 plus 17 is 4. 4 over 2 is 2. Negative 13 minus 17 is negative 30. Over 2 is negative 15. So we get our answers of x equals 2, x equals negative 15. Moving right along. Here we go. This one's already has everything on the same side. So we have a is 1, B is negative 34, and C is 289. So we have the opposite of B, plus or minus the root. Negative 34 squared is 1156 minus 4 times A times C all over 2 times A. 4 times 1 times 289 is equal to 1156. So I have 34 plus or minus 1156 minus 1156 all over 2. Anything minus itself is 0. Square root of 0 is 0. 34 plus or minus 0. 34 plus 0 is 34. 34 minus 0 is 34. So I just have 34 over 2, or 17. When you only have one solution, that would represent a graph where the vertex is our x-intercept. Remember, from when we did graphing, all of these solutions are showing us where the graph crosses the x-axis, those x-intercepts. If there's only one answer, that means that x-intercept is the vertex. All right, here we go again. Everything's already on one side. So we have A equals 1, B equals negative 6, C equals 2. The opposite of B means plus 6, so plus or minus the square root of negative 6 squared minus 4 times A times C all over 2 times A. 6 plus or minus the square root of 4 times 1 times 2 is 8. 36 minus 8 all over 2. 36 minus 8 is 28. 6 plus or minus the square root of 28 over 2. This time we don't have a perfect square under our square root. Remember, that's our radicand. Since our radicand's not a perfect square, we just have to reduce it. We have 6 plus or minus 28 is 4 times 7. So the square root of 4 is 2. So 2 radical 7 all over 2. Now this answer can be simplified. Everything here, 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 and here, all three of them can be divided by 2. So we can change that to a 3, that to a 1, and that to a 1, and get 3 plus or minus the square root of 7. Okay, you need to be able to simplify all of them, here and here. Both of those terms need to be simplified by that denominator if you're going to do that. All right, here we go. Get everything to one side first, so subtract 6x. X squared minus 6x plus 13 is equal to 0. A is 1, B is negative 6, C is 13. Opposite of B, plus or minus the square root of B squared minus 4AC all over 2 times A. 4 times 1 times 13 gives me 52. 6 plus or minus the square root of 36 minus 52 all over 2. 36 minus 52 is negative 16. 6 plus or minus the square root of negative 16 over 2. I'm seeing that negative under a square root. That means that imaginary unit I is going to come in. Square root of 16 is 4. The negative is taken care of by the I. So I have 6 plus or minus 4I over 2. Again, this can be divided by 2, so can here, and so can here. So we can change it to 3, 2, and 1. So 3 plus or minus 2I. This again is representing two different answers, 3 plus 2I and 3 minus 2I. We can't combine the like terms, or there aren't like terms, so we can't combine them, so that's where we have to leave it. All right, here we go. Again, subtract 4x, subtract 4x. X squared minus 4x plus 5 is equal to 0. A is equal to 1, B is equal to negative 4, C is equal to 5. Opposite of B, plus or minus the square root of B squared minus 4 times A times C all over 2 times A. 4 times 1 times 5 is 20. 16 minus 20 is negative 4. Square root of 4 is 2. Because of the negative, we get an I on it. So 4 plus or minus 2i all over 2. Again, all 3 can be divided by 2. So let's divide it out. 4 divided by 2 is 2. Plus or minus 2 divided by 2 is 1. So I could write 1i or just I. And 2 divided by 2 is 1. So I could write it as over 1, but nobody writes a denominator of 1. So we just leave it as 2 plus or minus I. Again, 2 answers. These are complex answers. Complex because they have a real part and an imaginary part. All right, these notes right here, right out of the textbook. So this here is talking about the discriminant. And the discriminant is just a name that we give all of that stuff that's going to be under that square root. So the discriminant is b squared minus 4ac. So to find the value of the discriminant, or find the discriminant, you just do b squared minus 4ac. Again, that's the stuff that is under the square root in our quadratic formula, b squared minus 4ac. So if you evaluate b squared minus 4ac and you find out that it's positive, you're going to be taking the square root of a positive number. That means you're going to be getting real answers. So if b squared minus 4ac is greater than 0, positive, you're going to get 2 real zeros. And if it's a perfect square, they're rational. But the important thing is if b squared minus 4ac, the discriminant is greater than 0, positive number, you're going to get 2 real answers. This one here, still saying that discriminant is greater than 0. Okay, it's a positive number. You're still going to get 2 real answers. This is just saying if it's not a perfect square, they're going to be those irrationals like 2 plus or minus the square root of 4 over whatever, or, well, not square root of 4, square root of 5 over something. If it was 4, you'd just take the square root. If the discriminant, b squared minus 4ac, comes out to exactly 0, that's when you're going to have only one real answer. And as it shows here, that is the vertex as your x-intercept. Again, your discriminant, b squared minus 4ac equals 0. That whole square root thing's going to disappear, and you're going to have a number plus or minus 0, and therefore you only get one number, and that's why you only have one root or solution. If the discriminant equals 0, you only get one real answer, and that graph would have the vertex on the x-axis. So the last case we can have is if our discriminant is a negative number, being less than 0. If the discriminant, b squared minus 4ac, is less than 0 or a negative number, you're going to get 2 complex roots. Those are the ones that are going to have those i's, those imaginary units. And again, that's because you're going to be taking the square root of a negative number, which is where that imaginary unit I comes from. So this asks us to find the value of the discriminant. So that just wants us to find b squared minus 4ac. So b squared, negative 11 squared is positive 121, minus 4 times 1 times 10. 4 times 1 is 4, times 10 is 40. 121 minus 40 is 81. This is greater than 0. It's a positive number, so I'm going to have 2 real solutions, and that is mostly what I'm concerned with, is the 2 real solutions. But since that is a perfect square, these are going to be rational solutions as well, meaning there's no radicals. You can write it as a fraction or maybe just an integer, depending on how everything else works out. But 2 real solutions is the important thing. Since it's a perfect square, they are also rational. Here, it's again already set equal to 0, so we can go right to b squared minus 4ac. B squared minus 4ac. So we do 8 squared is 64, minus 4 times 1 times 16. 4 times 1 times 16 is 64, so I have 64 minus 64, that's 0. Since my discriminant is 0, that means I am going to have only one real solution or one real root. One real solution or one real root, because our discriminant, the number that would be under that square root, was equal to 0. All right, one last one here. We have b squared minus 4ac. 2 squared is 4, minus 4 times 1 times 7. 4 times 1 is 4, 4 times 7 is 28. 4 minus 28 equals negative 24. My discriminant is negative 24. Since it's negative, I'm going to have two complex solutions or roots. Remember, roots and solutions are the same thing because it's set equal to 0 right here. Two complex solutions or roots. There we go, because my discriminant was a negative number. This right here, it tells us when we can use different methods, just kind of summarizes the different methods we've done: graphing, factoring, square root, completing the square, and the quadratic formula. Notice that the quadratic formula can always be used. Completing the square says it can always be used, but we talked before about reasons why you might not want to use it. The square root property is completing the square is kind of a way to make the square root property something you can always do. Talked about when you can factor and when you can't factor. We've looked at different things of that. And graphing is never a good thing if you're going to get decimals or big numbers, because you just don't want to draw a graph that big. All right, right here is your homework assignment. Have this ready to go for Tuesday. If you have any questions, let me know. Pause it here to write it down or pick it off Canvas. Have a great day.